Let's talk about a new board from China. What we have here is a WinnerMicro W806 MCU. It's a 32-bit MCU, and it runs at 240 megahertz, has 288K of RAM, which is really kind of odd, and 1 meg of flash. And as you see on the screen here, you see it, and then also the processor itself. Let's talk about the elephant in the room, though, and it really is an elephant. Let's compare it against a Raspberry Pi Pico, and as you can see, that board is quite a lot bigger than the Pico. And let's up the ante and throw a Raspberry Pi Zero in there. Now let's put this in perspective here. This is a SoC on a SBC, so single chip, a system on a chip on a single board computer versus a microcontroller. It is a 48-pin package. It has 44 IOs that can be used. 2 of them are ADC, and I'll look at the overall what it has peripheral wise in a few minutes. But anyway, it is a lot bigger, and that is kind of off-putting. That is one of my full-size NAND board. That's a and it's covering it pretty much. But anyway, let's look at the specs over here. And first, at the time I bought it, I paid $1.92 US, and I bought 3 of them with shipping for $9.64, which wasn't too bad, and that was on November 24th. Now, let's see what it costs now. They are up to around $3, and I guess the demands went up on them. And this board does not have Wi-Fi. There is a version with Wi-Fi. It's the W800 or 804, but I can't find those anywhere. I haven't seen any boards out on Aliexpress for sale with those. The only one that's out there is the 806. And again, it's from WinnerMicro. It's 240 megahertz. And this is really confusing here, but it's a 32-bit processor. It's got a CH340. And let's go down here to 1 megabyte of flash, 288 kilobytes of RAM, as PSRAM, so the pseudo-static RAM, and it supports up to 64 megs of external PSRAM, which might be pretty interesting to do something like a PLC or something like that with, because you could store your ladder or your programs inside that, and also have a lot of RAM if you wanted to for caching and buffering and stuff. It has 6 serial ports. It says 6-way, but it's 6 serial ports, which is kind of a lot, especially when you see what it doesn't have later. It has built-in LCD driver. I haven't done anything with that. Touch sensors, which is pretty standard now, 15. SPI, I believe there are 2 of those, and there is 1 I2C bus, just 1. So that's kind of strange, and I actually like multiple I2C buses so I can have a slave and a master. But anyway, and it has ADC and 4-channel, but it's 16 bits, but it only has a slew rate or sampling rate of 1K hertz, and that's kind of slow this day and age. Whereas if I remember right, the STC is it's like 200K hertz or so, somewhere around in there, and the Arduino is even is fast too. So even though it's at 10-bit, this is still kind of slow. And again, 44 channels of GPIO and 5 channels of PWM. Getting back to this right here, the ADC on this processor you probably wouldn't use because it's 4 channel, but you're going to lose 2 of it to your I2C because that's where your I2C lives. This is not listed on here, but it does have I2S also, one channel of that. And then 5 PWM channels, and they give the specs here, 3 Hertz to 160 kHz, and a duty cycle accuracy of 1 out of 256. So let's see, go down here and get a better look at the board. And also we'll look at it under the microscope too. But they give more information here. Let's see, what else? Yeah, this talks about the I2S controller, about the LCD controller, and that's about it for right here. But let's have a look at the board again. Okay, I have it running right now, and it's running the little blink sketch that I loaded on it. And this particular board, when I got it, like I said, I got 3 of them, and this one, the reset button did not work on it, so I desoldered the other one and put one that was a little bigger. That's the smallest surface mount reset button I had, so put that on there and it worked. I just had to solder into the ground plane that was exposed on the little holes there, so that worked fine. So programming, it's not too hard. You do have to download the SDK. Right now I do not think there's any or I don't know of any Arduino support for the IDE or platform IO. I'm pretty sure that'll be forthcoming because this will probably end up being a popular chip. But right now it's just not there. So but the SDK is not hard to use. It is a HAL based SDK, the hardware abstraction layer, like Giga Devices and STC uses for their boards, for their C API. So same thing here, is just about the same API. There may be some differences, but I haven't seen them. And let's see, let's have a look here. Let's see, there's the processor, as you can see here. Let's switch over to this guy here. So there's the processor, and as you can see it right there on the, and then that's the CH340. That's a 340N, so it's one of the smaller packages. So no extra external support. Then you have a AMS 1117 at 3.3 volts. Probably, I'm guessing a 0.6 milliamps, 0.8 milliamps, somewhere around there. I doubt it's an amp. And then your support, and you got a oscillator right there. And or is it a? Oh, that may be a crystal. It probably is a crystal. Seeing the 2 caps right there. So it just needs oscillator circuit for its internal clock, so it multiplies the clock because it is running at 240 megahertz, and that's a 40 megahertz clock or crystal. And then there again, there's your processor, about the size of a STC. It is smaller than a Raspberry Pi Pico processor. Comparable in a lot of ways, but I think overall the Pico is probably a little more flexible, with the exception of the if you can do it, but I don't see why you couldn't, because PSRAM is typically SPI, and but with SPRAM being able to access more of it natively is, to me, a plus. And you got your LEDs right there, and then your reset button, and that's the one that went bad on me, the other one. And it actually works on this one, and a boot button, and I do not know what the boot button does. There's nothing in the documentation about it. I haven't looked at the chip pinout yet, in the data sheet, but I need to find out where it goes. But nothing's in the documentation. There's nothing you have to do with the boot button to program it or reset it or anything, because you just reset it like you do it like an ESP to program it. So I'm not really sure. So, and again, it's a quite large board. I think they could have made this a little smaller, but I don't know. The quality of the board's not bad. And it is a plus. It is USB programmable, so you don't need an extra program or anything like that to do it. You just need the tools. So let's have a look at the tools. And this is the web page for GitHub. And for the SDK for it, this is actually the SDK with the demo programs and all the stuff for the 806. So this is specifically for the 806. You would download this, and let's see, why am I not seeing it all? Hold on. Oh, I'm in the demo, sorry. Get back over here. Okay, here you go. Here's the main page. And you would come here to this GitHub page, and I'll include links to all these, and download this guy. You can just follow these instructions, and these instructions actually do work, which is a plus also. And if you're not in China, go to this site right here, and I'll include it. This one or this one, and this will carry you to this page. And let me get this in here. Sorry. This will get you to this page right here, and get it straight again. There we go. And what you will do, and it tells you what to download, but you'll download. For me, I downloaded the Linux tools, so I grabbed this guy right here. If you're under Windows, you'll grab the MingW tools, and you'll be compiling under the sys tools for GNU, which I have not done, but it should work. I've seen other people in their blogs and stuff that they've done it, and it has worked. But if you're doing Linux, like I said, you download this or this for Windows. Once you download that, you go back, and we'll go down in a minute to here, and you just follow these instructions. You extract it, and there's Windows instructions down here for Windows users. Up here is for Linux and possibly, and there must be, okay, and Mac users. Where in Mac? Do they have Mac? Nope, no Mac. Mac, you can probably compile it and do it under the Windows, the Linux instructions. But follow these instructions, and you will be able to compile, and it will build everything, and then you'll be able to download a sketch to it. And again, I won't go any detail there. I'll do another video once I'm ready to show you how to build, and I'll also show you more about installation. Let's look at one of the demos here. Let's look at the GPIO, and this is their little HAL interface. You get the same thing when you do stuff for the Giga RISC-V stuff and STC compatible chips, ARM chips, and also with STC itself. So this is instead of WinnerMicro, it would be STC or Giga or GD actually for Giga. And your main program is here. And the interface looks just exactly the same as for those other chips. How GPIO read, give the when you want to read, your inits are down here. You got to start your clock for your GPIO engine, and your init, your write pin. All this works the same as those. So, and I'm sure again they'll do a Arduino wiring type interface for it, and a platform. I'm pretty sure platform will probably come first, where they'll pull the HAL libraries in, and so you can just click on your platform and download the whole thing from there. That's what I'm expecting. That's usually what happens. But there's a lot of demos out here. One of the things I did find, and before we go here, here's the demos that are included for the W806. But one of the things I did find when you go over here, here's this is from the datasheet. Here are all your peripherals. GPIO, UART, SPI, HPSPI, I2C, PWM, SDIO, I2S, LCD, analog, and watchdog. And it's got an encryption engine. Goes all the way up to AES 128, and then the RSA 256 here, RC4. So, medium level encryption, which, for microcontrollers is pretty good. And in your memory and your flash. But you'll notice right here, let's see, it's got DSP. Where's the DSP? Yeah, it's not listed here now, but it is listed somewhere. And that's kind of another thing about this, is where they have things listed. And to get the DSP and other peripheral examples, you'll need to download, and I found this out by accident, you'll need to download the W800 SDK. But you don't have to download the compiler or anything, because it uses the same compiler. You just have to get the stuff for the compiler specs and stuff like that. But let's see, is it over here? 806. I don't know how to look, but and I'll include that in the next video I have on the programming. But anyway, it was kind of strange they didn't have everything together, which is kind of inconvenient and poorly put together. But hey, it's free, I guess, other than the chip. But so far in my light playing, which it has been light, I haven't had any time to do anything major with it. It seems okay. Again, it wasn't hard to program once I get everything set up, and it really wasn't that hard to get things set up. My main stumbling block was getting the actual compiler tools, because when I first tried it, I was not able to get to any sites except the Chinese site, and I couldn't read it for one, couldn't get it translated. Google wouldn't work with the translator on it, and I just don't trust clicking on a lot of these Chinese links. I'm sorry. So yeah. Oh yeah, here they talk about this right here, the 804. Sorry, the 804 processor, which is the one with one of the ones with Wi-Fi, and it's got the built-in DSP. That's right, the processing right there. But it's not. It doesn't have a DAC per se, but it does have digital signal processing. But anyway, I hope this helped you. If it was me, I would probably wait a little while for it to settle down. Like the price again has kind of jumped into a little over a month that I ordered the chip from, from $192 to over $3 per. So, and then getting the development tools in a state that that normal users can do. I guess I'm counted as a power user. With things like this, I'm used to installing things like this a lot and having to muddle your way through. But it still wasn't too bad. But I would wait if I was most people. And then the second thing I'll have to say is just what the chip offers. I'm not really sure if it's a value in comparison to like the Raspberry Pi Zero. Excuse me, the Raspberry Pi Pico. This chip has more features and more flexibility. And that's just the truth, the honest truth. Neither of these have Wi-Fi. Like I have ESP 01 on this board that I made, that I can use the Wi-Fi from the UART. So, and you could do the same thing for this, but again, neither have Wi-Fi. But this is the more flexible chip. This chip is still readily available, as this one is too. So, but if I was starting out and I was going to buy one of these two, I would recommend this guy here. It's just more flight ready right now. But anyway, hope you guys enjoyed the video and it helps somebody, and have a good one.